Hello, student. This is your last chapter, last module, module number 4, frequency domain signal processing and analysis. Okay, so we will discuss in this chapter the frequency domain analysis and for the sensor signals. Okay, so up to now we already seen the all the type of sensors, why the sensor is important in the civil engineering and all. So sensors are increasingly used by practicing civil engineers to monitor, measure and remotely observe the world around them. Okay, so however these technologies are not present in a traditional CEE curriculum. Why we are study the sensors? Because they are widely used in your civil engineering field, so you have to have a knowledge about all the sensor functionality, so that in future whenever you face such type of sensors, so you will not get surprised that what is its functioning and how it works. Okay, so you have to have a basic knowledge about that sensors so that you can use in your work. Okay, so in this module we will study this content, like at the completion of this module you will able to explain the need for the frequency domain analysis and its principles. So first of all we will study whole concept of the frequency domain analysis. Okay, so then draw the conclusion about the physical processes based on analysis of sensor data. Okay, so what are the physical process based on the analysis? Sensor sense the physical condition and send the electrical signals. Okay, so either in an analog or digital form. Okay, so that data is important, and that data needs to be measured and needs to be stored, yeah, in order to draw the conclusion. Okay, so combine the signals in a meaningful way to gain a deeper insight into the physical phenomena. Okay, so combine the signals in a meaningful way. Okay, so to gain a deeper insight into the physical phenomena. Okay, so at the end we draw the signals from the sensors because we want to analyze this physical phenomena, any physical phenomena like a temperature sensors. So in that scenario we measure the temperature by using that sensor. So temperature is a physical phenomena. Then we can say that the pressure sensor is also one type of physical phenomena. Pressure, we measure the pressure by using the pressure sensors, and that data is stored in any form, like in any memory or on the web or anything. Okay, so in this module we will study these topics. So first overview. The basic concept in a frequency domain signal processing analysis is that we have to have a knowledge of Fourier transform, FFT, fast Fourier transform, and some concept of implementation of FET in a MATLAB or MathCAD. Okay, so this software is used to solve this complex frequency domain analysis. Okay, so these are the examples: noise reduction with filters. Okay, so the leakage, frequency resolution. So these are the problems which needs to be solved by using this frequency domain signal processing. Okay, so majorly we will discuss the Fourier transform in this module. So what is a frequency domain analysis of signals? So in engineering and statistics, frequency domain is a term used to describe the analysis of mathematical functions or signals with respect to frequency rather than time. Okay, so here one major respect is that frequency, not a time. Okay, frequency and time are different. If we divide the 1 upon time, then it will give a frequency. Okay, so keep in mind that. So in engineering and statistics, frequency domain is a term used to describe analysis of mathematical function. Okay, keep in mind that the frequency domain is what it is the analysis of mathematical function or a signals with respect to frequency. Okay, so we will analyze the any mathematical function or a signals with respect to frequency, not the time. Okay, the most common purpose for analysis of signal in the frequency domain is the analysis of signal properties. Okay, so we want to know the what are the properties contained in that signal. So we use the this is a common purpose for analysis of signals in a frequency domain. Okay, the engineer can study the spectrum to determine which frequencies are present in the input signal and which are the missing. Okay, so we can analyze all the spectrum of the frequency, and also if there is any noise or any other signals are present, then we can observe that, and also we can remove that. Okay, better and identify the characteristics of signal and add or subtract the frequency to the original signals. Okay, so if we analyze by using a frequency domain analysis, then we can do that, the better identify and add or subtract the frequencies. Then signals are converted from time or space domain to the frequency domain, usually through the Fourier transform. Okay, so now how we can convert these signals from time or space domain to frequency domain? By using a Fourier transform. So this is why Fourier transform is important in this frequency domain analysis, because we all have a time bounded signals. Okay, time domain signal, and if we want to analyze by using a frequency domain, then first we have to convert that signals into Fourier by using a Fourier transform. Okay, voice waveform in a time and frequency domain. So this is an example. Okay, so see this one demo voice waveform is shown. Upper side is a time domain. So time domain we can see that this is look like this, and in frequency domain it is look like this. Okay, so this is the all the spectrum. We can analyze all the spectrum, and if you closely observe that the amplitude where is the amplitude is high, the reddish portion is high there. Okay, so in frequency domain we can analyze all the frequencies contained in the signal. Okay, and in time domain we cannot. Okay, so that's why we convert the time domain signal into frequency domain by using the Fourier transform. So one important concept is a Fourier transform. Okay, so we have to have a knowledge about a Fourier series and Fourier transform. So first, what is a Fourier series? So a continuous periodic function ft. Okay, it is a continuous periodic function. It means that continuous means all the values are present for each time value. Okay, and periodic is it is repeat after some period. Okay, so these two term is very important. One is a continuous and second one is a periodic. Okay, if it is a non-periodic, then it means that it never repeats its pattern. Okay, but if it is a periodic, then it repeats the pattern after some constant time. Okay, so this signal is a continuous periodic function ft with the period t, or this period means this period t. After this period capital T, this waveform is get repeated. Okay, so can be expressed as a linear combination of sinusoidals, which is known as Fourier series. Okay, so we can express this function as a linear combination. Okay, linear combination of sinusoids, so we convert this signal in form of sinusoidals. Okay, and this is known as Fourier series. Okay, so this is a reference function. Ft is equal to summation u minus infinite to plus infinite au cos u into 2 pi by t. Here t is a time period of the signals, and into small t. So small t is a function time. Okay, and capital T is a period. Okay, so bu into sine u 2 pi by capital T into t. So by if we put all the values, then we get the sinusoidal form of the signal. Okay, then recall the Euler's formula. If you study mathematics in your first year, then you know what is a Euler formula. So by using the Euler formula, you can convert the signals into the this form. So e raised to jnx is equal to cos nx plus j sin nx. Okay, then Fourier series can be expressed as Fourier series also can be expressed like this. Okay, so these are the three questions which is very important for the Fourier series. Now, first is that we see the continuous signal. Okay, then now what is a discrete Fourier transform? So discrete time signals can be analyzed or decomposed into the series of sines and cosines. This represent is called the discrete. So continuous is a continuous signal and all the values are present, but in discrete some values are not present. Okay, so DFT presumes the periodic signals. Any periodic signal x with n points x0, x1 up to xn minus 1 is automatically assumed periodic with fundamental period t is equal to n into dt. So here it is not a perfectly periodic, this is a aperiodic signal, but we can convert this aperiodic into periodic like this. Okay, so this is a original signal and this is a assumed periodicity. So we assume that this is a signal present, so by using this we get the time period of that signal. Okay, so this is a discrete Fourier transform. So that one is a continuous Fourier transform. Here is a discrete Fourier transform. Okay, so rewrite the Fourier transform in a discrete form. So this is the original, this is the original, and this one is a discrete Fourier transform. Okay, so by a Fourier coefficient xu is a complex number, and then the amplitude and frequency of the component of the signal correspond to xu. Okay, can be defined as, so xq can be defined like this. This is a amplitude and this is a frequency. Okay, so amplitude is a real part of this, that xu square plus imaginary part of xu square and whole bracket. Okay, so by using this we can get the amplitude as well as frequency. Okay, so this is how continuous and discrete are different. So up to this, if you have any question, then you can comment it down, and otherwise we will discuss the next topic in a next lecture. Thank you.